Just one. Okay. Yes. Yeah, you can ask your doubts from the HR. Anything you want to ask from the eighth chapter?
No, ma'am. No
Just
doubts.
give me a minute, ma'am. I'm opening the book.
Sure. Yes. Abraham, you had some doubt, right?
Ma'am, the doubt that I had that is that I didn't understand the chapter at all.
Eighth chapter.
Yes, ma'am.
Okay. I'll plan it out, Abraham. Is it on YouTube?
Yes, ma'am.
Just go through it once, okay?
Okay, ma'am. No, ma'am, it's on YouTube, ma'am.
Check if you can find that on YouTube and go through the lectures once. And yes. So we'll start with the ninth chapter then. Okay. That's from the ninth chapter.
Ninth, 8th, or 7th?
Ninth. Okay,
Mm.
because chapter 7 doubts I'll be covering in the live. Backup class. Okay. Eighth chapter, if there's no doubts in the eighth chapter, maybe doing the ninth chapter. Okay.
Ma'am, then after I finish the 9th chapter, will you do the backup class of the 7th chapter?
Yes. If there are no other doubts, I'll be starting with the backup of seventh chapter.
Are we doing just simple interest today or both?
We'll do both side by side. Okay? We'll do simple and compound
Ma'am?
interest side by side. Yes, I'll do it.
Ma'am, many children found this chapter very tough.
But we'll revise it once again. Just 1 minute.
Ma'am, will you take a test of this chapter again or no?
I won't be taking a test again of this chapter.
You won't?
Please not test of simple and compound interest.
You can take
We've
test
already
of
taken
chapter
3.
6 and chapter 7, but not chapter 8 and chapter 9.
Especially now chapter 9. You've already taken 3. Please, ma'am.
Yes, I have taken 3 tests already, so I don't think I'll be taking a test anytime soon for this chapter. But once the course is over, I'll see. Okay. Once the course is over, that time I'll see. I'll plan something out, some test series or some revision classes. Okay. All right. So now simple and compound interest. I'll be starting with a very basic. Okay. Like since we are doing this topic, I'll be starting with the concept of interest. Okay. Now there is a person. Okay. And there is the bank. Okay. What happens Suppose this person deposits his money in the bank. In bank. Okay. Now, suppose he has deposited the money for 1 year. Okay, for 1 year. So after 1 year, bank will give his money back to him. Okay. After 1 year, the bank will give his money back to him. What he will give? Principal amount plus an additional amount, which is the interest. Okay. Because he has kept his money with the bank, now bank will additionally give him a little portion of the money. Okay, that is calculated on the amount he has deposited. Okay, how what rate? That is decided by the bank. Okay, on different types of deposits, there are different types of rates. Okay, there are RDs, okay, recurring deposits. Sometimes the rate is 5%, 6%. There are FDs, fixed deposits. Okay, that are long-term deposits where you keep the money for a long term in a bank. Okay, money is locked. You cannot take it back anytime you want. Okay, that is an FD. 2 years, 3 years, 4 years. FD carries a rate of 7%, 8%. Okay, that varies from bank to bank. Okay, now at that rate, after the completion of that time period, you will get an additional amount along with the amount you deposited. Okay, the amount we have deposited is the principal amount. Okay, the additional amount that you are getting from the bank. Okay, that is known as interest. All right, this is one case. Now, interest is also when what happens, you have taken a loan from the bank. You have taken a loan from the bank. Okay. Now, suppose you have taken a loan for 1 year again. After 1 year, when you will deposit the money to the bank, after 1 year, when again you will give the money to the bank, what you will give? You will give the principal amount, means the loan amount you took, principal amount plus interest. Okay, you'll have to pay the bank a little money, okay, in the form of interest, okay, along with the principal amount. All right. Interest rates are sometimes 2.5%, 3%, okay, 4%. Those are the interest rates, okay, on different types of loans. Okay, loans are also there of different types, car loans, house loan, okay, and different form of loans are there. So on different types of loans, different rates of interest they carry. Okay, so that you have to pay after the completion of the time period. Okay, say after 1 year. All right, so this is the concept of interest. Now, interest is of two types. Okay, simple interest and compound interest. All right. Do you want to write this or shall I move forward? Shall I take it?
You can
Go forward, ma'am.
You've already talked this before.
Okay. Yes. Now, interest has two types, simple and compound interest. Who's going to tell me the major difference between simple interest
Ma'am?
and compound interest? Yes.
Ma'am, simple interest and compound interest have two different formulas, ma'am. Ma'am, simple interest is PRT by 100.
Okay.
Then
Any
compound
other
interest is A equal to P into 1 plus R by 100 to the power of N.
Yes, besides the formula, any other difference? Yes, Anaya.
I was just going to say what Edric was saying.
Okay. All right. So now, if we talk about the concept of simple interest and compound interest, what is the major difference between both of them? Is that simple interest is calculated on the principal amount for every year. Okay. But compound interest is calculated on the principal amount plus interest of the previous year. Okay. Like interest on the principal amount plus interest previously that is accrued. Okay, means all the interest that is generated previously, we take the principal, and on that we calculate the next interest. We keep on calculating the next interest on that. Okay, this is the one major difference. That in simple interest is levied on principal amount only.
Ma'am, do I
Whereas
have to copy this or no need?
that's up to you. Okay, if you want to write this down, you can write. Whereas in compound interest is levied on principal and interest previously earned.
Wrong spelling of principal.
Principal previously earned. Okay. Now, see, tell me, look at both of these concepts and tell me which type of interest will generate more wealth, will wealth
Ma'am, compound
accumulation
interest. Ma'am,
in
compound
which
interest.
one will be higher? Compound interest, yes. Wealth accumulation in compound interest will be higher. Okay.
Ma'am,
And in simple interest, it will be lower. What is wealth accumulation? Exactly. Means that how much money is it generating, how fast it is generating. Okay. Like compound interest will generate you more money quickly, whereas simple interest it will take time. Okay. In simpler words, compound interest will give you higher returns comparative in comparison to simple interest. Okay, compound interest has higher returns. How? Look at this example. Look at this example. Rupees 200 invested with a rate of 3% for 2 years. Okay. Year by year we will see. Okay. Don't think about the formula right now. Okay. We'll put it, but year by year we will see. Okay. First, let's do in the case of simple interest. Okay. For the first year, year 1, TRT by 100. Okay. So, because we are doing only for the first year, so 200 into 3 into 1 by 100. What will it be?
Ma'am, 6.
Yes. Then for the second year, 200 is my what?
7 it becomes 200. Ma'am, A equal to SI plus P. That means 6. That means 6 will be added to 200.
Yes. So 6 rupees is my interest, simple interest, okay, for both the years. So in simple interest, my total interest is 12. Okay, that is
But in
6
compound interest,
12. We'll see what happens in compound interest. Okay?
oh, in compound
Now,
interest, this 200 will become 206, I think.
now year 1 interest in compound interest is the same.
Yeah. And year 2 it will change.
Year 1 interest is rupees 6, okay, as it is. But year 2, what we'll do, what I said, like in the definition, levied on principal and interest previously.
That means become 200 plus 6. 206 into 3 into 1 by 100.
Yes, so 200 plus 6, the principal will become, it will give us 206. Now we'll calculate it with 206. Okay, so it becomes 200 206
206 into 3 into 1 by
upon 100. Okay, we will get 6.18. 6.18. Okay, now both the years, total this is, okay, that is 6 plus 6.18 gives us 12.18 rupees. Okay. So can you see now that in compound interest, I have higher amount of interest. Right. This is compounding. What's compounding again? Levying the interest on the principal and the interest that's previously earned. Okay, on the principal and interest previously earned. On that total, we calculate the interest. Okay, then we have this interest. Now on the previous, all the interests and the principal, we'll calculate the interest for the next year. This we keep on doing. Okay, now if we don't have to do it again and again and again, we have our formulas. Okay, for the compound interest. Hello, Simran. It's okay, Simran, no problem. Happy birthday.
Thank you.
Yes. Simran's birthday today.
Happy birthday, Simeon.
Thank you.
Okay. Yes. So we are doing simple interest and compound interest, Simran. Okay. I have taught how how there is difference in the returns of simple interest and compound interest. Okay. Go through it once. Give this a read, all of y'all. If you want, you can write it down. And if there is any doubt, you can ask me.
Ma'am,
Quickly. Yes. Yes, Edric.
simple interest is easy to calculate, but it gives less money. Compound interest is harder to calculate, but it gives more money.
Yes, we can say that. Give it a read, Samir, and if there is any doubt, just ask, please. Hope you'll know how I calculated year one interest. It's the same, okay? TRT by 100. Shall we move forward now? Okay. Yes. Now we'll move forward to the formulas, okay? We'll see formulas once again. We'll take a revision of that. Okay. Now, simple interest formula, very simple. Principal into rate into time upon 100. TRT by 100. Okay. Now, like I have explained that compounding of interest, what is it? Like adding the, like calculating the interest on the principal and the previous interest. Okay. Now that is done in three different time periods. Okay. Like three time periods are followed in it. Three types of time periods are followed in it, on which our formulas are based. Formula is same, but three types, it's calculated on three types. So we change that a little according to each time. Compounding is done annually. Annually means
Half
every
yearly.
okay, at the end of every year, at the completion of 12 months. Then we have half yearly.
I mean, end of every 6 months.
Yes, at the end of every 6 months. And then we have quarterly.
Quarterly. Ma'am, quarterly means end of every 3 months.
Yes, end of every 3 months. Okay. Now, how many quarters are there in a year?
Ma'am, 4.
4 quarters. Okay. And how many half yearly parts are there in the year?
2. 2.
2 parts. Okay. That is why in our formula we make the rate, we divide the rate by 2 if we have half yearly, if the compounding is half yearly. If the compounding is quarterly, we divide the rate by 4 because there are 4 quarters in a year. Okay, so let's write our formulas. We have compound interest. First is when compounding is done annually. Our formula now in compound interest, there are two steps. Okay, to calculate it. First step, we calculate the amount. In the second step, we calculate the compound interest. Okay. Now the second step is the same in all three of the formulas. Okay. Like, however, in whatever time period, according to whatever time period you are doing the compounding, the second step, that is compound interest, we subtract the principal from the amount. We do CI equals to E minus P. That's same for all the three parts. Okay. First for the amount, we have amount equals to principal 1 plus R by 100 raised to the power n.
N.
Okay. The time or the number of years, you can say. Okay. Then you do CI equals to amount minus principal. Okay, this is the second step that remains the same in all three. Then second is when you are doing the compounding on half
Half.
yearly basis. Okay, so compounded half yearly we have amounts is equals to principal. Formula remains the same. We divide the rate by 2. R by 2 by 100 raised
Power
to
of
the power
2n.
2n. Okay, because we have 2 quarters in a
Wait, no.
year.
2 halves in a year. 4
Yes,
quarters.
yes. 2 halves in a year. Okay, and then the third one, compounded quarterly A equals to P 1 plus R by 4
By 4.
by 100 raised to the power 4n.
4n.
Okay, then you do Ci equals to A minus P. Here also, after the in half yearly also amount is calculated, then we will do Ci equals to A minus P. Okay, this is the all of the basic formulas to calculate the compound interest. Okay, now this amount formula is very important. We use it in almost all of the cases. There are cases where you are not given the value of the principal. Okay, you will be given the amount, you will be given the rate, the time. Okay, principal you have to find. That case is also the formula that's commonly used as the amount formula. You put in the values, okay, put P where principal is not given, and solve for the principal. Okay. Then also sometimes there are cases when rate is not given or when time is not given. Now, do you all want me to do one question for all of that, or you can go through it by yourself?
We can go through it.
You all can go through it. Okay. So today, what I want you all to do is go through all of the cases. Okay. Try out one question where you are not given the principal and you have to find the principal.
Ma'am,
Where you're not given the rate, you have to calculate the rate and the time as well. Yes, Andre.
ma'am, the difference formula?
The difference formula.
Ma'am, the difference formula is only used to find the P.
Yes. Difference formula to find the P. What's the difference formula?
P into, okay, difference equal to P into R by 100 is power of n.
Difference equals to P into R by 100 to the power of n. Now, further in this chapter, there are points where you are given. Now, there are, see, two types of questions again. Okay, one where you have to find out the difference between simple interest and compound interest. Those questions don't use this formula. Okay, when you have to find out the difference between compound interest and simple interest, don't use this formula. Use the compound interest formulas for compound interest, simple interest formula for simple interest. Find out the interest, find out both, then subtract the simple interest from the compound interest to get the difference. Okay, that is where you are asked the difference between CI and SI. Okay, you have to find the CI and SI and then take the difference. But when you are asked to find the principal, when you are asked to find the principal, that time and difference you are given in the question, you will be given with the difference. That is, Ci minus Si is this much. what is the principle. That time you have to use this formula. Okay. You can take a look at the last exercises of chapter 9. Okay, it's in that where you are given the difference between CI and SI. And principle you have to find out. That time use this difference formula. Okay. Clear?
Yes, ma'am.
Okay. All right. So this is about difference. Take the next 2 days. Okay. And try out one question from each topic, from each concept. Okay. Try out one or two questions from like each type of questions you can try out. Where some value is missing, the others are given. Okay, I want you all to try that out at home. Also try the difference questions also one or two questions you can try from the difference as well. Okay. Just take the exercise, open it, pick out any random question. Okay. Like from the topic, pick out any random question and just try to solve it and see if you were able to solve that. Okay. Also, revise the formulas, but don't look at the formulas while you are solving it. Okay. And try to remember and write the formula on your own. Okay. You should know the formulas. All right. All of them. Okay. So we will stop here. We'll stop the compound interest class here. And if there is I'm giving you today's also, go through it, this chapter, ninth chapter, go through it once again. If still there's any doubt in any of the other concepts too, like finding P, finding R, finding the N, or anything else, okay, you can ask me tomorrow. All right. Anything else? Okay. So, okay, then I'll see you tomorrow. Bye.
Bye. Happy birthday, Simeon. Bye.
Thank you.
Okay, 5 minutes break, and then we'll be starting with the science. Okay, hope you all are there. We are going to start the class right now. Videos on, please. Now, we'll be doing the types of images today. Okay, the two types of images, that's real image and virtual image. Okay, real and virtual images.
Didn't we already
So,
finish this chapter?
yes, we finished this chapter, but there, and I was having a little doubt in it, so we'll go through it again. Okay, we'll go through its formation, how they are formed. Okay, we'll quickly see that. And firstly, I want to ask, what do you like think the difference between a real image and a virtual image is? The basic difference between a real and a virtual image.
Sorry, what now?
The basic difference between a real image and a virtual image.
That's like what I had doubted. I wasn't understanding what
Mhm.
real and virtual image is.
Okay. Anyone else? No? Turn on your cameras, guys. Turn on the videos. Okay. Let's see. Now, real image and virtual image. So what happens in a real image? Now, light rays in a real image, light rays converge at a specific
Is that
point.
why did you draw like that number line kind of thing? It looks like a number line.
Number line kind of thing. It's I think to show parts of something. Okay, because I'm telling you, teaching you about the difference between the real image and virtual image. I have separated it. Okay, like how I say that you can make flow chart, just a thing like that. Yes, Anand.
No, it's okay. You complete what you're saying.
Um, sorry, I didn't got that.
I didn't realize I was interrupting. I'm sorry. You can complete what you were saying at last.
Okay, all right. Yes, I was saying that real images are formed when light rays converge at a specific point after being reflected. Okay, where the actual intersection of light rays is taking place. But virtual images, there is a virtual intersection of light rays after they are being diverged. Okay, that is an imaginary intersection. Okay, not an actual intersection in a virtual image. Also, we'll see how the real images are formed in the front of the mirror, but the virtual images are formed at the back of the mirror. Okay?
Several real images form when light rays converge at a point in front of a mirror or lens after reflection or refraction. But virtual images form when light rays diverge after reflection or
Yes, when our light rays diverge after reflection. Okay, that's right. And in the virtual images, they diverge, but when we join those, there is just an imaginary intersection of the light rays in virtual image. Okay. How that happens, again, how that happens, I'll show you. Suppose, let's do the real image. This is a concave mirror. We will make a principal axis where the object will stand, okay, where the object will be there, will be placed. This is my object. All right, now the light rays will fall on the mirror. Okay, and they will get reflected. And where these reflected rays will meet. This is my light rays, okay, that are traveling, falling on the mirror. These are my reflected rays, okay. These are my reflected rays. And this is the point where they are both meeting, okay. This is the point where both of them are meeting, where my image formation will take place, where the real image will be formed. And real image is inverted. Okay, the real image is formed inverted. Why is the real image inverted and the virtual image erect? Why? Because the real image is forming below the principal axis. When an image forms below the principal axis, can you see this line on which my object is standing? The straight line at the center, that is my principal axis. Okay, this line is my principal axis. Okay, this is my object. Okay, these are my reflected rays. Okay, now when an image formation takes place below the principal axis, it will always be an inverted image. Okay, now since the light is falling here and since the concave mirror is reflecting the light rays in such a way that the intersection of the light rays will take place below the principal axis, the image will also be formed below the principal axis. Okay, now when the image is forming below the principal axis, it will be an inverted image. Okay, it will be an inverted image. And real images are inverted images. They are formed in the front of the mirror. Okay, this is what this portion is the front of the mirror. They are formed at the front of the mirror. They are inverted. Okay, the real images. All right. Whereas, what happens in the case of virtual images? Let's see the formation. This is a convex lens. let's make the principal axis. Okay, we have the principal axis. Now let's make our object. This is our object. Okay. Now the rays of light this is diverging. Okay. So ray of light will be reflected here, and this ray of light will be reflected in this direction. Okay. Like how they are coming. They are coming like this and being reflected like this. Okay. Now if we extend them behind the mirror, what I said, imaginary intersection. What is imaginary intersection? I will extend this
Not
reflected
happening.
ray here, okay, and this reflected ray here. Okay, so now there is an intersection taking place behind the mirror. Now, intersection is taking place at this point behind the mirror. So this is where my virtual image will form. This is where my virtual image is formed. Now, virtual images are erect. Okay, means they are not upside down. Okay, they are not inverted. Why? Again, why? Because now this intersection of this imaginary intersection is not a real intersection, okay, because it's happening behind a mirror. They do not intersect actually, but they appear to intersect. They appear to be intersecting. Okay. So now this intersection is taking place above the principal axis. Okay, this is my principal axis. Okay, this line is my principal axis. It's taking place above the principal axis. So image formation will take place where? Above the principal axis, due to which it is erect. Okay, due to which the image is erect, not inverted. All right. So if it is asked that why are real images inverted, whereas virtual images erect, so you can answer it like that. That because the intersection of the reflected rays is taking place below the principal axis in the real image. So because the real image is forming below the principal axis, it is inverted. Okay, whereas a virtual image is forming above the principal axis, they are erect. Okay, inverted. And here they are erect. This is another difference between the real and virtual image. Okay. Hope you got the formation of the real image and the virtual image, how they are being formed, how a real image is formed with the concave mirror. Also, real images are formed with concave mirrors, and virtual images are formed with
Could you
convex.
just give an example of, I mean, like how you gave example
Um,
for swimming?
can you repeat it?
Could you give me an example of each? Like how you gave an example of the convex and concave mirror and a spoon?
Sure. Now, real images, they are formed by a lens or a curved mirror. They are real images can be called the images that are formed on a screen. Okay. Also, the images which are formed on the retina of an eye of the eye is also a real image. Okay. Images formed on the retina of our eye. Then the image is formed on a screen, okay, by a lens. That is the real image, or image formed on a photographic film can also be a real image. Okay, but with the examples of the image formed on a virtual image. Okay, it can be the image of an object that we see in a plane mirror. Okay, the images that we see in a plane mirror are all virtual images. Why? Because they are forming behind the mirror. The virtual intersection, the imaginary intersection is taking place. They are formed behind the mirror. So the image of any object we see in a plane mirror is a virtual image. Then the image seen through a ref- plane refracting surface like glass or water. The images that we see on the surfaces that reflect the images, such as such as water or glass. They are also virtual images. Okay. Then in myopia and hypermyopia also, like I have taught you, right? Myopia and hypermyopia, the image formation, those are the eye defects. What happens? Virtual images are there. Okay. Virtual image formation is taking place. Remember how I taught you the how the image formation will be taking place behind the retina.
Yes, you
Remember?
showed us the video also.
Yes, yes. So that can also be an example of a virtual image. Okay. But real image, it will be formed at the retina. Okay. Virtual image will be myopia will be an example of a virtual image. All right. Even the images we see through a telescope or something. Okay. Telescope or periscope, those images are also virtual images. The imaginary intersection of the light rays. Okay. I hope it's clear.
Yes, ma'am, now it's clear. Thank you.
Okay. Okay. Anything else? If you want, you can take a picture of these diagrams. Okay. Give a read to both of them, the real image and virtual image. Give a read to the differences. I think I've shared the differences of both in the two. So I'll give them a reading. Abraham got it. As part is back of the mirror. Okay, so any other doubts from the real and virtual images?
No, ma'am.
Okay, from the light chapter.
Yes, ma'am, I have a question. So myopia is also called nearsightedness, right? I mean, like when you can't see things that are close by.
Mm-hmm. Yes.
So is it like the same? Is it like the same type of illness where you can't like read? I mean, like when you need reading glasses. Are both of them the same thing or they're different things? Like when people can't read, when people can't read, some people can't read without reading glasses, right? And myopia also, you can't see things that close by with you
Mm-hmm.
without a concave lens, right?
Yes, that's right, Anaya. People who are not able to see the close things, like their reading problems, it's due to this reason only. Okay, that they are unable to read a book or the things that are close. They are unable to see it clearly. It's due to this reason only. Okay.
So having reading glasses is like a symptom of myopia, and like when you're not able to read those things.
It can be said
Okay.
to be a symptom of.
That was my only other doubt. Yeah, that's I understood the rest of it.
Mhm. Okay. All right. So how are the presentations going?
Good, ma'am.
Good. Okay. Tornadoes and earthquakes clear?
Sorry, what?
Tornadoes and earthquakes clear? Who's
Yeah,
doing what?
yeah, they're clear. So Abraham's doing a tornado, he said. Siemens doing an earthquake in Gujarat, and I'm doing an earthquake that happened in Japan.
Wait, Simeon's doing an earthquake in the Gujarat? I thought you were doing tornadoes, so I changed my entire case study.
Yeah, I'm doing tornado.
Simon, didn't you say that you were doing an earthquake then?
Who's doing tri-state? Tri-state who?
No, and Simon said he's doing a tri-state tornado. And then he said that I'll do a Gujarat earthquake because then will have to do something else. That's what you said, right? Remember yesterday?
Did
Simon?
something else in I did the Joplin, Missouri tornado 2011.
Okay. So if both of y'all are doing tornadoes, but different tornado, then it's okay. Like if Simeon's doing tri-state and Abraham's doing
But
Gujarat.
Abraham's also doing a tri-state.
Not doing,
That's what he said yesterday.
not doing tri-state. I'm
Not
doing
doing tri-state.
Missouri 2011 tornado.
Okay. All right, then it's fine. Like it's all right. Hope it will be done by this Friday.
Yes, ma'am, it'll be done.
I'm almost done already.
Okay. Abraham, Friday.
Yes, ma'am, I'm almost done with the PPT. Just the last
Okay.
activity I've completed.
Mhm. Okay. All right, then that's good. So, all the best, prepare well, and go through it once again, so science chapters. Okay. And we will stop the class here. But if there's any doubt in any other topics also, you can ask me. Okay.
Ma'am,
Any other chapter? Yes, Abraham.
the presentation. Can we have a joke? Can we have some jokes in our slides?
Can you have some what? Jokes in your slide? Yes. Of course, you can put some jokes.
Everyone.
So you want us to be creative, you said, right?
Yes, yes. As creative as you want, you can be. It's good.
What kind of jokes are you going to put?
That will come to know on the day of the
Okay,
case
Abraham,
study.
don't tell. It will be a suspense. Okay.
Yeah.
Okay, ma'am.
Yes, I mean it's gonna be a suspense, a surprise. So we'll Abraham will reveal on the presentation day itself. Okay. Okay then.